Welcome back, everybody. This is going to be part 1 of 3 in my lecture series on solving systems of linear equations. Let's get started. When I'm talking about a system of linear equations, all I mean is a set of lines. So a system of linear equations in 2 variables is just a pair of lines, and an ordered pair that falls on both of them is a solution. So, for example, if I wanted to look at a graph, if I've got 2 lines, maybe I've got one like this, and then I've got another one like this. These guys would both be modeled by some equation like y equals mx plus b, and there is exactly one point that falls on both of them in this case. So this would be the solution to the system. Now, there are 2 primary ways that we can solve systems of equations. One of those being substitution, which we'll talk about in this video. The other being elimination, which we'll save for another video. And by the way, this is probably my favorite topic that we're going to cover in our class. So, this is an example of a system of equations. Notice I've just got 2 lines, although neither of them are written in slope-intercept form or point-slope form for that matter. This is what we'd call standard form. So, I'm asking you to solve this system of equations using substitution. How do I do that? Well, the first step in the substitution method is to write one variable in terms of the other using one of the equations. It doesn't matter which equation, just pick one. So for the purposes of this problem, I'm going to just pick the first equation. So for equation 1, notice it'll be a little bit easier to solve for x than for y because x doesn't have a coefficient. All I have to do is, starting from here, subtract the 3y over. And that gives me that x is equal to 11 minus 3y. Okay, step 1 is complete. I'm going to highlight that in orange. Now, step 2 is to use this representation in the other equation. Notice here, I didn't specify which one to start from, but whichever one you started from, you're going to go to the other one to get an equation in one variable. Let's see what that means. Now, if I'm finding a solution, it should satisfy both of these at the same time, right? So whatever x value my point has, or excuse me, whatever y value my point has, x should be 11 minus 3y. I'm going to use this representation of x in my other equation. So notice I have x minus 5y. Now we're going to equation 2. X minus 5y equals negative 13. Well, now I'm going to use that 11 minus 3y instead of x. Minus 5y equals negative 13. Now, I need to combine like terms to get 11 minus 8y equals negative 13. I'm going to give myself a bit more room here. I'm going to subtract the 11 over. That will give me negative 8y equals negative 24. And now I divide both sides by negative 8. Oh, and excuse me. I guess I'm doing step 3 here, which is to solve that equation in one variable. So why don't I do this here? This work goes here. Okay, all better. So now I divide both sides by negative 8. Cancels on the left side. I'm left with y equals 3. So here is the y coordinate to my solution. Oh, how do I get the x coordinate? Well, I go back. Oh my goodness. There we go. I go back to the original equation. I plug this solution into one of the equations to solve for the other variable. But notice this guy's already set up for x, so I'm just going to borrow that one. I get that x equals 11 minus 3y, but y, I now know, is 3. Times 3. So, x is 11 minus 9, or 2. So altogether, the solution to the system is the ordered pair 2, 3. And now I want to show you something. So you'll notice here that I've sketched the graph of both of the lines from our problem. In red is x plus 3y equals 11, and in blue is x minus 5y equals negative 13. And sure enough, the point where they cross here is 2, 3. That's the solution to our system. Let's try this problem. Let's solve x plus y equals 4 and y equals 3x for x and y using substitution. Well, step 1 is already done for me. Notice the second equation is already solved for one variable. It's solved for y. So step 1, check. We can just move on to step 2, which is I'm going to plug equation 2 into equation 1. And that's going to give me x plus y, but remember y is 3x according to the bottom equation, is equal to 4. Combining like terms, I get 4x equals 4. And then I divide both sides by 4 to give me that x is 1. Step 2 and 3, check. Last but not least, step 4 is I'm going to plug this back in to one of my equations. I'm going to use the bottom one, y equals 3 times 1, to get me y equals 3. Check. All said and done, the solution to the system is the point 1, 3, or the ordered pair. Remember, you should have an ordered pair as your solutions. One last problem for you. But this is a bit of a challenging problem. Go ahead and pause the video here to see if you can tackle it on your own, but if you need a hint, let it play a little longer. Ready for the hint? The hint is to fully simplify the system first. Nothing says you can't start messing around with these equations. In fact, that's what substitution is all about, right? And elimination, but we'll talk about that in the next video. So, your hint is to fully simplify that system first by combining like terms. In the first equation, I can add this 2x over to the other side, and I get 4x minus 3y equals 8. In the bottom equation, I can subtract the x and the 3y over to the left side to get 2x plus y is equal to 14. Now go ahead and pause the video to see if you can finish it off. The answer that I found was 5, 4. Feel free to pause the video here to check over my work. In this video, we saw how to solve systems of two equations using substitution. In the next video, we're going to learn about elimination. Catch y'all in the next one.